So using your prior knowledge, which statements do you think are true out of the 4 statements I gave you if ABCD is a parallelogram? Yay, Carson, good. What'd you do? Okay, so what do y'all think? Opposite sides are congruent. Put your vote in. What do you think? True or false? Okay, if you guessed true, you were right. That's actually one of the properties of parallelograms, that the opposite sides are the same length. So if I take this side and I measure it, it should exactly equal, well, come on, it should exactly equal that side, which it does. And if I take this side and I measure it, it should exactly equal that side. Cool. Next one, angle A is congruent to angle C. True or false? What do you think? Let's test it out. Angle A, is that going to be congruent to angle C? Whoa! Perfect match. Couldn't be more perfect, so that's another true statement. Next one, the diagonals are congruent. Well, we're on a true run. What do you think? The diagonals are congruent. The diagonals, by the way, are the dotted lines. What do y'all think? Put a guess in. Come on. Get brave. Let's test it out. I don't know if I can test this one. Will it let me? Whoa, what do y'all think the answer is? Totally, completely. No, it's not true. Look how different. Congruent means the same length. Is that green segment? Is this the same length as this? No way, it's way longer. So AC is much greater than BD, so they are definitely not congruent. False. And last one, AB is parallel to DC. Well, it is a parallelogram, right? So some things are going to need to be parallel because that's in the name of it. So you're right. That one is true. I'm not really going to prove that one. I already took this segment and slid it over here. It had the same exact slope. So I think we're good on that one. Okay. So like I said, we are starting our quadrilateral unit. Quad means 4, yes. So our shapes are going to have 4 sides. Obviously, I put that up there. So let's talk about each shape that we are going to discuss during this unit. And then today we'll focus on parallelograms only. So what is this first shape called? Ooh, it's a parallelogram. What is this next shape called? If you thought square, you're correct. What about this shape? Too easy. Rectangle. Well, it is a square though, because I made it a square. What about this shape? Trapezoid. We're not proving them squares yet, Mean Jung. We're just kind of discussing the different shapes. What about this shape? Did you see that? Rhombus. No, none of them are, they're all quadrilaterals. We're being more specific. And this last one, does anyone know what that last one is called? Good job, Adriana. That is called a kite. It sure is. So those are going to be the shapes we're going to study, and we're going to do it in this order. Whoosh. We're going to do it in that order. Okay? So, did you receive a copy of this? Maybe? Maybe not? Yeah, you were right. It really was a kite. That rhymes. You were right. It was a kite. I think this is on the calendar. It might not be on the calendar until Monday. But this is going to be called your quadrilateral family tree. You don't need it right now. It's not a big deal if you didn't get it yet. And your family tree is where you're going to store all the properties for all the quadrilaterals. Now, you're going to have to memorize these, but it's not going to be a big deal because you're going to use them so much that you're just going to memorize them by default. You'll have them memorized. So, like I said, today we're going to focus on a parallelogram, and it has 5 properties. So today we're going to zoom in and talk about and dissect the 5 properties of a parallelogram. And then we'll save other days for all those other shapes. Okay? So we're taking notes right now. Parallelogram. Opposite sides are parallel. So here's some pictures of some parallelograms. There's a school bus lift that's nicely in the shape of a parallelogram. There's a restaurant. Do you see that restaurant overlooking that lake or ocean? I don't really know. I don't remember where it is, but that's a really pretty restaurant. It's a parallelogram. Maybe. It might not be a perfect one, but let's pretend. And then here's someone who is bored and they folded their chip bag into a parallelogram. And then here's a building that's got some nice parallelograms built into the structure. So, okay. So, a parallelogram has 5 properties. We talked about that. 5 properties. And so what we're going to do is we're going to list those 5 properties. So in your notes, I want you to write A, B, C, D, E. A, B, C, D, E. Write them in your notes. And I gave you hints to each of the property. So what I want you to do is write down the name of the property given the hint. So that second one is opposite sides are congruent. That's what those tick marks mean. Very nice. What about C? What am I trying to communicate in C? So C is opposite angles are congruent. D, I'm just going to end your misery and tell you what I was going for on this, although I know you could have had a lot of other conclusions. On this, so the opposite angles are congruent. We've already said that. This one I was trying to get at, what's the relationship between these 2 angles? We're going to call those angles consecutive. What's the relationship between those 2 angles? If the opposite ones are congruent, then the consecutive ones are supplementary. Yes. You typed 180, but I knew what you meant. Consecutive angles, sup. So opposite angles are equal, consecutive angles add up to 180. That's what I was going for with that, although I know that there were other conclusions you could draw from that picture. And finally, E. Can anyone get E? I'll give you a hint. You need to use the word, this is called a diagonal. You need to use the word diagonal in your answer. Yay! Good job, Minjung. Diagonals bisect each other. Very good. So as you can tell in this unit, there's going to be a lot of vocabulary. We've got words like opposite, congruent, supplementary, bisect, diagonal, consecutive. Lots of words. We need to keep, we need to keep track of all of our different words and what they mean and what they imply. Okay, so I'm going to go through each property one at a time, but you've probably already written them down. I just want to make sure we're good on all of it, okay? The definition of a parallelogram. It is a quadrilateral with both pairs of opposite sides parallel. You've probably already written this down because we did that on the last slide, so I'm going to go quickly. Okay? So, these sides, if we wanted to prove that they were parallel, we would need to know their, not their length, but their slope. Thank you, very good. Okay, so this line right here has a slope of 0, and this line right here has a slope of 0. So that's how I know that they're parallel. And then if we were on the coordinate plane, we could find the slope of this side and the slope of this side, and they would equal the same number. They are sloping the same amount. So the next property is opposite sides are congruent. They're the same length. That one's pretty self-explanatory. The next property, opposite angles are congruent. We already talked about that. True or false? If I know one angle of a parallelogram, I know all angles of a parallelogram. If I know one angle, I know all angles. True, yes. So if this angle is 32 degrees, then that forces this angle to be 32 degrees. And then the next slide is going to say consecutive angles are supplementary. So you would just need to find the supplement of 32. 148. And then you would then know all of your angles, okay? All right, so like we said, consecutive angles are supplementary. Consecutive angles are angles that share a side. So the 60 and 60, those are opposite. The 60 and the 120, those are consecutive. I want you to also think of those angles. If you think to last semester, these are parallel lines, boom, boom. This is a transversal, so I also want you to think about those angles as same side interior angles. And remember, same side interior, that starts with an S, so they're supplementary. So that's another way to remember how they're supplementary. Another thing I want you to visualize, I'm giving you lots of tools. If you ever forget what the relationship is, I want you to picture this angle. I want you to picture it being drug up here and placed right there. These two angles, angle 1 and angle 2, are now a linear pair. They form a straight line, so they add up to 180. So lots of ways to remember to keep track of whether the angles are congruent or supplementary. The last one is that the diagonals cut each other in half. So if this diagonal was 20, then I know that this diagonal cuts it in half, making it 10 and 10. Now, the diagonals are not congruent. That was not one of the properties. They are not the same length. So that one could be 10 and 10, and this one could be 7 and 7. So they do cut each other in half, but they are not the same length. So just be careful about that. One last thing is kind of like a bonus property, although it's not one of the 5 properties. One last thing is that something cool happens if you draw one diagonal of a parallelogram. If you draw one diagonal, you know some things. For example, you know if you're looking at triangle 1 and triangle 2, you know that this side is congruent, right? You know that alternate interior angles are congruent. You could do it again. You could do alternate interior angles congruent. And you could say, oh, wow, those are congruent by angle, side, angle. Or you could say, oh, it's a parallelogram, so opposite sides are congruent. And they're congruent by side, side, side. However you want to paint the picture, we know that if you draw a diagonal, you make 2 congruent triangles because it's a parallelogram. So that's kind of a bonus property if you want to write that down. The diagonals divide the parallelogram into 2 congruent triangles. So triangle 1 is perfectly equally matched to triangle 2. So whatever you know about triangle 1, you can just rotate it and it would fit with triangle 2. Okay, let's do some examples so we can actually apply these properties. Every example you're able to pick one of the 5 properties that you just learned and you're able to use it. So let's see which property we're going to use in this example. Given quadrilateral ABCD, this is really important. When we are placing letters on the quadrilateral, here's what you cannot do. A, B, C, D. You cannot jump across the quadrilateral to name it. That would be naming it incorrectly, forcing you to solve your problem wrong. So be really careful. When you're naming a quadrilateral, you need to name it in a circle. I don't care which way you go. I don't care if you go counterclockwise or clockwise, but you need to name it in a circle. No jumping across the figure. So I'm going to do A, B, C, D. All right, AD is 6x minus 3. AB is 5x. And BC is 4x plus 17. Find the perimeter of ABCD. Oh, it's not showing up. Is it showing up on yours? I totally wrote it on the screen. Can you see it on the screen? It's like the, oh, there we go. That's wrong. It's wrong. Woo! Okay. Here we go. So, what are we going to do? What are we going to do? We're going to use one of our properties, and it's still not showing up on here. We're going to use one of our properties, and that property is going to be opposite sides are congruent. We're going to use that property. Opposite sides are congruent. So, I know that this side is opposite this side, therefore they're congruent. You're going to have to look through the camera because I don't know why it's not sharing my screen. Can you see through the camera? So we're not going to use the 5x right now because he's not opposite anybody. We're going to use the 6x minus 3 and we're going to use the 4x plus 17. I don't know what's happening. Camera's down. It's not down on mine though. Yeah. Okay, so we've got, have you already solved it by now while you were waiting for me to get my camera back up? 6x minus 3 equals 4x plus 17. What'd you get for x? 10. Yes, very good. X is 10. So we've got 60 minus 3. So that's 57. I don't need to plug it in there. I know the opposite sides are congruent. So 57, 57. And then I'm going to plug it in here. So it's 50. And I know opposite sides are congruent. So it's 50, 50. So we're really making those properties work for us. So then we just add these up and we get 214. Is that what y'all got? Oh no. Example 2, we're going to use a property. This one's pretty easy to know which property to use. We're dealing with angles this time, and one of our properties says that opposite angles are congruent. So that's easy. Let's just set them equal so that we can move on to some better examples. 6x minus 10 equals 2x plus 10. 4x equals 20, and x is 5. The measure of angle D, let's see, 6 times 5 is 30, 30 minus 10, so we got 20, and then we know that consecutive angles are supplementary, so we're using our properties, very good, and we know that 180 minus 20 is 160. When you know one angle, you know all 4 angles of our quadrilateral. Let's move on. Find every missing angle of the parallelogram. Give y'all a second to draw it. The cool thing is that we can use our old properties. Like alternate interior angles, we can use that because this is a parallelogram. We've got parallel lines and we've got transversals. So the first thing I would do is I would do all of my alternate interior angles. So I would say 18, 18. 25, 25. Make sure you're placing it on the alternate side of the transversal. 88, 88. So now I've done all the alternate interior angles I can do. Now what? We do have that property in our notes that says consecutive angles are supplementary. So I know angle B, angle C, those are supplementary. So I know all of angle B, if I add up that whole angle, and then all of angle C will add up to equal 180. So all I have to do is add up 18, 25, and 88, and subtract it from 180. And I know that my missing angle right there, right here, is 49. You can always check yourself. Add up all four of those numbers, and you should get 180. Oh, well, now that I've found 49, I can use alternate interior, 49, 49. And the only thing left to do is use triangles. Now we can use triangles. So we can take a look at this triangle right here. And we can add those up and subtract from 180 because we know the angles of a triangle add up to 180. So we're going to get 67. And then we know vertical angles are congruent. And then we know that those form a linear pair, so 180 minus 67. I am showing you one way to get all of these angles. I bet you found other ways to get them, and that's fine too. Can we move on? I hope so, because we've kind of lost some time due to connection issues. All right, let's try this one. If the measure of DCB, is twice the measure of CBA, find the measure of BAD. So whenever you have problems like this, you might want to use the letter X to help you. I know that the red one is double the green one. So I could call this X, and I could call this 2X. And then we remember that consecutive angles, that weird word, consecutive angles are supplementary. So I know that angle B plus angle C has to equal 180 because they're same side interior angles. Cool? So this one's 60, which makes this one 120, which makes this one 120. Final answer. Okay. Getting close because I know we're about to run out of time. ABCD is a parallelogram. Just solve for X and Y. So you're just trying to figure out what those two equal. Y is probably easier to solve for than X. You should probably solve for Y first. Doesn't really matter. To solve for Y, I would use alternate interior angles. So 6y plus 5 is 35. 6y is 30. So y is 5. And then 5x, you have some options, good job, but let me show you an option that I haven't used yet. To find x, you can just use this triangle if you want. There's other ways to get it, but you could just use this triangle. And you know that all three of those angles add up to equal 180. So you know that 5x plus 80 plus 35 equals 180. So x is 13, yeah! Very nice. Moving on. I'm actually going to save this for Monday because we ran out of time. So this will be in Monday's lesson.